Hello, everyone. So I'm going to talk about column storage for the AI era. I thought it would be a good idea to start with an image that is not AI generated to illustrate my point. So just to show that we could make images that defy the laws of physics before Gen AI existed. So it's kind of a little bit tongue-in-cheek. Okay, so I'm Julian. I'm part of the ASF, and I'm also part of the LFAI and data, working on several open source projects in the data ecosystem. So today we're going to talk a bit about more Parquet specifically. We talk about how it was designed originally, some of the praise and gripes, what people like, didn't like, and what has changed since then, right? And how this is influencing the format and what we can concretely do as next step as we're evolving. So first, to go back a little bit in times and talk a bit about the design, right? So the project was started in 2012. It became the de facto standard for columnar storage. It's widely supported, and it enabled the interoperability for the new generation of vectorized query engine that got inspired by CStore and MonadDB, X100 paper. We will talk a bit about that. At the time, there started to be a flurry of SQL and Hadoop, of various things like that. We were trying to make things faster than the original MapReduce enabled. It's based on the Google Dremel paper. And if you remember at the time, if you were based on the Google paper, yeah, you were on the right track. Right? Like Hadoop, MapReduce, HGFS were all both based on Google papers. So the main trade-off at the time were based on one, reducing the cost of storage, so getting better compression. Another one, to trade off decompression for CPU, right? How long it takes to decompress something. Of course, the more it's compressed, the less time it takes to transfer on the network, and the more time it takes to decode on the CPU, right? So finding the right trade-off between those things was one of the key driver for this design. One of the benefits of columnar storage is when you do analytical type queries, you usually accept a subset of the columns, and data is also partitioned horizontally in row groups. So using statistics and columnar representation, you can only get the data you need from the disk, right? So it kind of gets things faster. And the Parquet file has a footer that describes the content of the file. So things are organized in row groups. You can have only one if you wish. Each row group has column chunks, which is the data for that column within this row group. And each column is decomposed in pages. The pages is a unit of encoding and compression. There's a little header that describes how the data is encoded. And so to access the data, you read the footer, you find the columns you need. You can use the stats in the footer to skip if they don't match your predicate based on the statistics. And then you can read only the columns you part, and you find in the file the things you're interested in. The page is there's two levels of encoding. So the first level, right, you take the values, and the encoding is something that's aware of the type of the values and encode them in bytes representation, hopefully a more compact one. And then there's an optional compression, more generic compression algorithm apply on it. You can think of it as usually it's Z standards nowadays. So it's more generic compression that takes any bytes and compresses them. And it is optional. So things people like, this gets good compression because of the columnar layout. When you put together all the data at the same time, you can use an encoding that's more effective at compressing data. And you also compress together data of the same type, so it compresses better than if you interleave data of multiple times in rows. It is self-describing, right? So the Parquet file knows about its schema. You know exactly what the data looks like. And we remember we used to live in a world where we had CSV files. There are lots of type inference, or like the reader needed to know what the schema was. So we made it harder to share data and so on. It enables data skipping, and it is one of the key advantages. It's a de facto standard, right? There's wide adoption, there's interoperability, and there's an active, engaged community of implementers that collaborate on improving it over time. So some of the things people don't like, I don't know, like usually I make the joke that maybe I skip that part because if you're not interested, I'm sure people are interested, right? So one of the things is it's not parallelizable enough, right? Like one gripe that people will mention, it was designed before like GPUs were big things. SIMD also become a bit wider, so it's not parallelizable enough. I was talking to someone who implemented decoding of Parquet on GPUs, and he was asking, "Hey, why did you make it so hard to parallelize?" Well, because 13 years ago, or 14 years ago now, parallelism, making it more parallel was not like a focus yet at the time. We didn't have as much parallelism. The trade-off of CPU for storage was not as important. Another inconvenience is the metadata becomes large when you have many columns. At the time, we didn't have as much of those very wide schema use cases like we have for feature stores now. And so the metadata tends to be quite large and also doesn't let you skip easily in the metadata to look only at a few columns among many. It's also not optimized for random access, right? There's a bit of read amplification because when you want to read one value, the minimum size you decode is one page, right? Like, so if you use ZDSTD and we're a bit reliant on generic compression like this, it compresses well, but it requires decoding the entire page, right, to read one value. So there's a bit of read amplification. So we talk a bit more about what has changed in both in the technology and in the use cases, especially now that we're doing a lot more AI than we used to, and how that changed things. So first, there's more parallelism. So I did a little bit of a study for over 15 years of how things have changed, right? Like we have a lot more cores on high-end servers than we used to, from about 8 cores per server at the time, like to 128 now. SIMD becomes a lot wider. So SIMD is a single instruction, multiple data. It's when you telling the processor apply the same instruction on those 4 values in parallel. So there used to be 128 bits, and now there's 512 bits, right? So you'd have 4 times as many values. So instead of 4 values, you can process 16 values at the same time. GPUs also have a lot more parallelism. When I say threads running on GPUs, threads are a bit more like SIMD, which is evaluate the same operation in parallel many times, right? So we have a lot more parallelism. Of course, the wider CPU compounds with the more cores, right? You have 4x wider, but you have 16x more cores. So you get a lot more parallelism than we used to. Another thing that changed is the AI access pattern, right? When you have a vector store and you're trying to implement RAG and you're going to look up your embeddings, retrieve some data, then feed it to the LLMs, do other things, you actually have a lot more need for random access pattern when you're going to read a subset of the data in the file, and you need to be able to reduce the latency, how much it takes to do that. So that's where this read amplification that you need to read more data to achieve that becomes problematic. So what can we do about this, right? Like, so there's a healthy pressure that comes from newcomers. So over the past 5 years, there's been quite a bit of research on new encodings that take more advantage of parallelism, like including better blocks, ALP, fastlane, FSST. You can look up those papers. They're very interesting. And they've been pushing the limits of how much parallelism we can get of an encoding and improving the ratio of compression for time in text to read the data. And there are a bunch of new file formats that are been coming out. In particular, I think 2 in particular stand out with Lens and Vortex. They've both been contributed by companies that work in either multimodal or vector search or feature store space. And enabling those new use cases. And they are applying this new research when picking the encodings they use in their file format. And you also have a few other formats. There's Nimble that's coming from Meta. There's some research formats like Fastlanes and F3 that also explore different ways to do things, and they demonstrate the effectiveness of new techniques. And more importantly for me, they're lighting a fire under the incumbents, like existing formats, by proving that, okay, some things need to change, and how do we evolve the ecosystem? So one question you would ask is like, oh, but have things fundamentally changed, right? Like, okay, we used to optimize for analytics and lots of scanning and lots of throughput, and now we're optimizing for more random access. Are those things fundamentally different and we need different formats? So I would argue that they are not that fundamentally different, right? These new formats, they also are columnar oriented. They follow this similar structure. So of course they do certain things differently. And we should take inspiration of that. But fundamentally, we're still laying out the data in columnar representation, and then some of the features is particular in length, for example, that are more related to table formats like Iceberg, and there's some other features that are more related to the file format instead, in particular the encodings and how we encode the data so that we can enable better random access. So one thing to clarify, I think you might think of Parquet as a file format, but I would argue that before being a file format, it's an open source project, right? And as an open source project in a consensus building machine, it's a mechanism for the industry to agree on how we're going to do something, right? And I would argue that it is easier to popularize new techniques through the existing machine rather than having a lot of fragmentation, right? Like building the community around the project is a hard part of the project, and we're standing on the shoulders giant. Like Parquet just adopts new techniques that are based on breed of like in the industry and in the research. So I'll give an example. Last year, we adopted variant type in Parquet. And just to show you the process and how that works, right? It came from a proposal from Databricks. There was a bit of a discussion of which project should contain the definition of that new type and how it works, from Spark to Arrow to Iceberg. We finalized the consensus. It went into Parquet. We worked together as an industry, and you get collaboration between Databricks and Snowflake and Data Fusion, like whether it's open source or vendors having to collaborate on how we make this happen, right? And then where the co-opetition happens is like, then we build cross-compatibility tests. We make sure once we agree on the spec, we build the implementation. We make sure everything's interoperable. We didn't miss anything. And then you get the benefits of something that gets adopted that is broadly supported in the ecosystem. So, some people, I said, oh, but you can go faster than this. Well, like, try, it takes a bit of time, right? Like that's part of the open source and building consensus and making sure we all agree. It takes longer, right? And then it's just like one thing we're saying is, if you want to go fast, go alone. If you want to go far, go together. So it takes a little bit more time, but it's worth it. So we're talking about, I was asking the question, are those needs at odds, like between more throughput, like being able to do OLAP and scanning a lot of data quickly versus doing random access? So the good news is if you dig into this, actually those two characteristics, they benefit from the same thing in the encoding, right? Like the same things that enables reading more data in parallel faster and accessing one value independently of the others is the same characteristic, which is we're trying to avoid having dependencies between two values in the encoding. So if we take the example of something like a delta encoding, and the delta encodings basically take the approach, if you take numbers, they're usually in a certain range, right? Like, so you compute the deltas between two consecutive numbers, and those numbers are going to be much smaller, and then you can bit pack those and encode them in a much efficient manner. The downside of this is to read any value, of course, you need to decode them all because you need to add up all the values preceding to get there, right? And when you apply block compression like this standard, for example, you also need to decode all the bytes before the value you want to read so that you can decompress to that point. So all those properties, they create read amplification for doing random access. And so that's the kind of properties we want to avoid. And the same property, when you can read a value independently, you can also decode all the values independently, right? So that same property of avoiding dependencies from one value to the next and allows you to read one value by itself or reading all the values in parallel, right? Because they don't depend on each other. So that same property enables both. And actually, those new encodings I was talking about, they are focused specifically on enabling fast decoding of a lot of values in parallel. But because of that, they also enable making random access faster by allowing decoding fewer values to get to where you want to get. So, and we're covering, there's a encoding for floating point, ALP, encoding for integers, fast lane, that use frame of reference, different type of encodings. FSST is an encoding from strings. Better block is a way of combining those encodings, like ALP basically turns float into small integers, and those small integers, then we can apply integer-based encodings to encode them better. So all those encodings basically give you a good coverage of all the types you can find in those tables to encode them better. So the concrete next steps of what we're doing. So some of the things you can do to tune for random access is tuning the existing Parquet settings, right? Like Parquet has row groups, but you can have only one if you wish. That's become more efficient in blob storage. Parquet, like if we say the unit of decoding in the page, you can make the page smaller, and pages can be of varying size, right? So you can adjust on a column per column basis, and you can make it better for your random access use case. This standard might be too slow. It is optional, right? Like some of the trade-off is using those encodings and encode better and like not doing the block compression so that you can do faster random access. And some of the encodings don't allow random access. So you want to enable random access. You want to explicitly saying, I don't want to use those encodings that are hard to parallelize and don't enable random access. And also, some of the cases, like the reason why we have more columns is sometimes when we do feature store, we add more columns and those columns are pretty dense. But also in other cases, we have columns that are very sparse, meaning there are few values defined in many columns, and that's where variant shines in combining multiple columns that are very sparse together and getting a better efficient use of columnar storage, because columnar storage is not going to be very good at having many sparse columns. And it's not like a Parquet thing, it's just a columnar storage thing. So that's where variant will enable getting things better. We can make better use of metadata, right? Like parts, like the reading the metadata is on the path to access the value. In a lot of cases, when we build databases, you can cache the metadata. It's usually stored somewhere else. Like Iceberg, for example, also caches some of the metadata, and so you don't always go through the footer. So we are making the footer better, but it's also not necessary requirements. So a lot of those encodings are being added to Parquet as we speak, following the same process we follow for variant. ALP is being finalized, so we're in the process of getting a much better floating point encoding in Parquet that enables random access and gives a lot more parallelism for decoding faster floating points in parallel. Fastlane is not yet in progress. We started working on the frame of reference type encodings that are better than delta encodings to enable parallelism. So Parquet is a community effort. You are welcome to contribute. In general, you get one person that is driving one effort, and then the rest of the community collaborates and in building multiple implementation and validating that works. The FSST encoding, which is for strings, is in progress. We're still finalizing the spec, and we're not completely finished on that, but we're working on it. And there's also a proposal in progress for a better footer format that enables better random access. And so some of the things is not like I wanted to insist on. It's not that you have to either create your own format or contribute to Parquet, right? We can layer things, right? Like for example, in Data Fusion, there's a good blog that explains how to embed custom indices into Parquet, and so you can extend Parquet, right? Keep the data in the same format. Of course, new encodings is something that needs to be in the format, but newer indices, things better access to the metadata that we store something else. It's all things you can layer on top of the format to build a better database on top. So this kind of gives flexibility of keeping compatibility while enabling you to innovate and build new things like vector stores or things like that. And on that, this is my presentation, so I'll be happy to answer questions.
Awesome, Julien, thank you very much. This was excellent. We're going to let a couple of people ask some questions. I'm still seeing them trickling in. So until then, let me just ask you a couple of things first. So how do people start to contribute? If they are so inspired as to jump in and make their contributions to Parquet, how do they get started?
Right. So the main communication medium is always the mailing list, right? So you can sign up on the mailing list, you can ask questions, you can see what people are working on. And of course, we keep track of progress on in the GitHub repository using tickets and tracking contribution. In addition to that, we have a bi-weekly online meeting where everybody is welcome to come contribute their agenda item. You can just show up and say what you want to talk about, and you have a group of people happy to help. So this usually the synchronous communication through the online meeting helps getting the asynchronous communication move faster. That is happening on the mailing list.
Yeah, I like how you put it that Parquet is primarily not a data format, but a consensus engine as an open source project. Nice. Let's see. We have a couple of questions here. Victor is asking, maybe I'll put this up on the stage. Let's see if anybody else can see it. Can you guys see this now? Can you see the question? Let's see.
Yeah, sorry. Yeah. Is a column storage solution better or more efficient in the scale of terabytes of data, so it's future-proofing in a way? So usually columnar storage compresses better, right? Because the columnar layout and it brings data of the same type, and also it gives you a better access because typically it depends how many columns you have, right? But typically you have a certain number of columns, and when you access the data, you access a subset of the columns, and so it gives you better access to this data. So for a bunch of use cases like this, column storage, has become the state of the art, right, for all the data-oriented access. When you have more reads and more querying of the data than modification on it, right? It's a better layout for queries, for big queries.
Nice. Okay, we got another one here. Let's see. Thank you very much, Victor, for the question. Can you tell us about the challenges in maintaining an open source format with all the AI advancements, and what strategies are being employed for safeguarding?
That's a whole other talk. So actually, I've been talking a lot, right? Like, so the thing with AI coding, right? Like you want to keep a tight loop. Like what people have been working on is how do I keep my coding agent do the right thing, right? Like because if you just throw a random prompt and it's capable of generating a lot of code, and so if you break the loop of the person who prompting and the person who gives the feedback, then you get a bad dynamic, right? Like what we started seeing is like people putting a quick prompt to Claude or whatever they're using or Codex, and then they open a PR, and then they let the maintainers review the output, right? They don't look at it, and then the maintainers review the output. So that's a very bad practice, right? Like because the quality, the reviewer doesn't even know how you prompted the agent. You cannot give feedback, so that's a very bad pattern to do, right? So there's been a lot of pushback from open source project and saying like, don't do that. Don't open a PR that's purely generated by AI that you didn't review. You as the contributor, you're the first reviewer, right? Like we accept contribution for humans, not from automated things that haven't been given good guidance, right? So there's a bit of that, like, and so people have been working on not just like giving good guidance, but also how we can use AI for automating code reviews, right? Like, because as the volume of code that's being submitted increases, of course, the reviewers get swamped, right? Like, the maintainers get swamped. So how do we leverage that for a better way of dealing with a higher volume? And I know we've been exchanging how do we deal with this. And I think, yeah, it's important. You can only submit AI generated code if it's been through a thorough actual, like, making sure it's high quality before I send
Right.
it to maintainers.
Right.
Otherwise, the maintainers, they're on the receiving end of all the things, right? It's really easy to generate a ton of not high quality code.
Did you see that there was like a scandal a few weeks ago with the NumPy contribution? I think it was NumPy.
Was it the thing where, there's an autonomous agent that
Yeah,
wrote the blog post because they were discriminated against?
exactly. They
That
said, "What do you mean you're only taking contributions from humans? That's discriminatory." And
right?
then they
But
sought to
I mean,
destroy the
to me,
life of the maintainers.
to me, it's just an elaborate joke, right? Because when this happens, basically there's an owner to the bot, right? We kind of prompted it. Oh, and be if someone is just like prompting about to say, hey, be like offended
This
when people
aggressive,
discriminate
yeah,
on you, right? Like, an LLM doesn't have feelings, right? There's just like generate text based on the prompt they've been given, right? So this kind of, I would not take it. It's not discrimination. It's just saying, like, no, you
you're not
guys,
being
you cannot say.
speciesist. You're not anti-agent.
I'm not anti-agent. I'm anti putting random prompts and letting me review the output of it, right? Right? Like, it's kind of the person who generate the code has to take responsibility in the prompting they're giving and giving feedback and making sure they produce good output and not just like quickly whatever comes out of it, right? Like, it's not I write the code, you do the review, right? Like, no, 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 no. Like, the same person is responsible for the whole thing, and in the end, we help you getting through. But you cannot decouple the person who produced the code and the person who give the feedback, right? Like,
Sure.
because the maintainers can do that too, right? They can use agents.
Yeah.
They can give better prompts, right? So if you're just going to read the ticket, give it to the agent, send the code, and then copy the feedback from the PR to the agent, the maintainers can do that, right? Like,
Yeah.
you're not providing any value as a
That's not
contributor
enough.
by just passing strings around, right? So that's how to think about it, in my opinion. So yes, totally automated agents are not that useful because you need people to give the right context to them. And it's not, sorry, I'm not going to think I offended the LLM's feelings, or I'm discriminatory to something that's been prompted to give answers that are,
That's okay.
yeah.
I think we all understand. Whether the agents will understand is a whole other question. I don't know, but one day they'll let us know. Julien, thank you
One
very
day,
much. We have
yes.
many more questions in the chat that we didn't yet get to, which is also a reminder for people in the audience: upvote the questions that you want us to serve, and let those questions in. Type them up as soon as you can, so that other people can have the opportunity to upvote them. Julien, thank you very much. This was excellent and fascinating work that you're doing. So I appreciate you coming.
Thank you. And hang out in the chat to answer some of those questions if I see them.
Awesome.
Bye bye.
All right. See you, Julien.